Hello, my name is Tanya. Student ID 1133700210. We are group 16. I will briefly introduce the research question, variables and data collection. Our research question is whether there is a difference in average daily water intake over the past year among groups with different primary drinking water sources. For the variables, we have an explanatory variable and a response variable. The explanatory variable is the primary drinking water sources, including boiled water, bottled water, and public water dispensers. It is classified as a categorical variable. The response variable is the average daily water intake in milliliters over the past year. We divided the water intake into 6 intake intervals and converted each interval into a midpoint value for analysis, and it is classified as a numerical variable. Regarding data collection, we collected a total of 203 responses. After excluding 9 missing values and 6 invalid responses, 188 valid responses were included in the final analysis.
Hi sir, my name is Zhong Zhaohong. There is my student ID 1133700240, and we're talking about what statistic method we choose. So we choose one way ANOVA to be our statistic method because the independent variable x is a categorical variable which include the boiled water, bottled water, and public water dispenser, and the depend variable is continuous variable, right? Since we cannot be 100% confident in the accuracy of the collecting data, we graded the water consumption and remove the my variable as the output result. And we also can make sure that all of our data are independent, right? Because they're from different subjects, and we can make sure there are no relationship between of the data. And keep going, look on the figure 1, there's how we transform the data. So if the student answers he drink the water is between 0 to 500, we just choose the middle one, 250 be our output. And if the student answers his water answers the number is between 500 to 1000, we also choose the middle one is 750, and so on. Then the figure 2 is show what is our data look like. You can see where 3 type of different way that student can get the water. We have the sample number from each group. Like the boiled water we have 47, the bottled water we have 84, the public water depender is 57. We also have their mean, standard deviation, and 95% confidence interval. Like in the boiled water, the average student drink 1,526.5 milliliter of water, and the group bottled water is 1,279.7. The public water dispenser is average water they drink to each day is 1,390.3 millimeter. They also have their standard deviation 792, 700 Na748. Also, their 95% confident interval will between these two numbers, will between these two numbers.
Moving on to our visual integration, the box plot shown in Figure 3 provides the visual comprehension of water intakes across the three groups. We can see that the distribution overlap considerable, and the median value are relatively close. And lastly, each group shows a wide range of water intake value. This overlap suggests that any differences in average intake may not be statistically significant, and our one-way ANOVA produces the F statistic of 1.683 and p-value of 0.189. Since the p-value of 0.189 is greater than our significance level of 0.05, we fail to reject the null hypothesis. To further our investigate, we perform Tukey's HSD post-hoc test. The pairwise comprehensions produced p-value of 0.164, 0.621, and 0.661, which is all greater than 0.05, indicating that none of the pairwise differences are statistically significant.
Hello everyone, my name is Fangli Chen. My student ID is 1133700202. Now let's look at the conclusion. Based on ANOVA test, FCC equal 1.C183, p-value equal 0.189. Since the p-value is higher 5%, we refer to reject the null hypothesis. There is insufficient evidence of statistically significant difference in daily water intake among the three groups. We believe the large within group variation may have lowered our statistic power to detect small difference. Limitation. Regarding the limitation, first, it's an observation study, so we cannot establish causality. Second, the self-report data introduce potential recall bias. Third, we have an unrepresented sample and unequal group size. Furthermore, we didn't account for confounders like weather or physical activity. Finally, converting interval data into midpoint value might now fully reflect actual water intake. Thank you everyone.